Hello everyone, and if you can hear me, if you can see me, please set the thumbs up in the YouTube chat, so I will know we are good to go already. And there is Cedric to join me in a moment. I guess we are going to do a lot of great things today. Hello. Yeah, good to go. Perfect. So give me a moment to grab Cedric. Yeah, very happy to see you. Hi Vikrant. I see some familiar names in the chat. That's amazing. Please, sorry for the delay. So I'm bringing Cedric to us. Hi Cedric.
Hello.
So let me add you to the screen so people will see I'm not alone. Oh, you are on the screen already. That's incredible, but I have a thing to fix.
Yes, because now it's like
Yeah, you are too green, and
I'm
I
too green.
have to fix that. Okay, good, and very transparent. So that's not going to be like this. Yes, because color I need is just green, not custom, and you will be fine.
You do. And
Close.
now everybody knows our dark secret.
Well, we never made any kind of a secret out of that.
Oh no, not at all.
Okay. Good. Now you are very well set.
Yeah, boom, magic.
Much better than I do. But I'm sorry, I have a solid excuse. I've just moved to a new apartment and my studio is not completely set. I hope you will forgive me. In the end, you are here not because of me, but because of the knowledge we DataStax developers, advocates are bringing with DataStax Monday Learning. So, welcome everyone. Finally, we can start. Welcome to DataStax Monday Learning, our way to make your Monday better. And that's Alex Voloshev and Cedric Lunven on the Terraform it infrastructure as a code. And the Terraform it you can read as Terraform it or Terraform IT because both are perfectly valid. And we are moving on. So, as said, that's a part of the DataStax Monday learning program. Every Monday, well, okay, almost every Monday, we are trying to bring something new, help you upgrade yourself, and help you to unlock no new skills. We always ask you to bring your friends as well, because it's absolutely free. There are no attendance limits, and so on and so forth. As long as YouTube can hold us, well, we can accept everyone who wants to learn something new.
Okay, so we should be fine.
Yeah, looks like that. So, what's going on with DataStax Monday Learning? This week, we speak about infrastructure as a code. Incredible new approach, and that's what this session today is about. And next time on 21st of December, so 2 weeks later, we have one incredible expert speaking about Ceph. It's a high capacity distributed storage. You know, we are at DataStax very into the distributed and high capacity things, but usually that's about Apache Cassandra. And now we will speak, our guest star will speak about Ceph, which is kind of a different thing. Two words about me. I hope some of you know me already. I work at DataStax as a developer advocate, and I run this Monday Learning thing. And we work on many of the different things to make developer, especially Cassandra developers, a best of the best, knowledgeable, certified, and so on. And today with me is Cedric. And
Yes, so I'm leading the advocate team at DataStax. I'm kind of the Java geek. I created and maintain FF4J for 7 years now. And I also had the chance to contribute a little bit to Jeepster. I should do that more, especially regarding Cassandra, because we need to share the love about Cassandra. But not today. Today's infrastructure as code, Terraform.
Yeah, exactly. And oh, I forgot to mention that about myself, which is my bad. My favorite open source project I'm working on right now is Grafana Cassandra integration. We have metrics collection for Apache Cassandra for a while, but we never had a direct, straightforward integration to read time series data from Cassandra to Grafana, and now it's possible with Grafana Cassandra data source under development with me and some very nice team. Okay. So, a few things we are going to use today, and if you attended one of our previous workshops, you know at least part of that. We do streams at YouTube, primary channel, and Twitch, which is more a plan B or backup. So, if you ask us questions on Twitch chat, mostly probably you will not get an answer. To ask questions, as said, you may just use YouTube chat, but that's not the best option because as soon as stream is over, chat is closed and we cannot answer you anymore, we cannot elaborate on any questions and so on. So our weapon of choice here is our Discord server, Fellowship of the Cassandra Rings, where we cover multiple different topics and you always can chat with other people. We have multiple thousands of people at the Discord server, I believe, and also other experts talking about these kind of topics. I hope we have link to Discord in the YouTube stream description.
Yes, and I put the link on YouTube chat.
Thank you so much, Cedric. When our hero of the day is Terraform by HashiCorp. It's a great infrastructure as a code tool we will work with today. And after the workshop, I publish all the tools and slides as you usually like us to do on GitHub, so they will stay available forever. And record of the stream also stays available forever. So if you missed something or you have to quit earlier, then no worries, you always can jump back. Two more things. This one workshop is going to be a little bit shorter than usually. Usually we try to do around 2 hours. This one is going to be shorter. And this time we don't do Menti. So join us for Menti. We next Menti quiz we do. Cedric, what do you think? This Wednesday? Do we?
So this Wednesday we will do some rehearsing to pass the Cassandra certification.
Indeed.
So this is kind of the workshop where we do dry run. So we ask you 20 questions, which is very look like what the certification would look like. And so there will be Menti there for sure.
Yeah. If you are here for Terraform and you don't know DataStax developers, there's a nice surprise. You also can pass all the educational course and the certification exam and become a certified Apache Cassandra developer absolutely for free. It's a courtesy of DataStax. And that's a great program. Ask us in the chat if you are interested. And well, in general, you should be because Apache Cassandra is one of the most powerful databases of those days. Okay then. So, let's start. I guess it's a good time to start.
Yes, let's go.
Yeah, let's go. So, infrastructure as a code. That's a main topic for us today, and we will also discover some tools. But what is it, and what does that mean? Official definition sounds like infrastructure as a code is the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. As always, that doesn't sound really helpful because those kind of definitions like not clear enough, and there is nothing better to learn a new technology than to start to use that. So we will walk through how it works and cover the most well-known tool in this world, but first we have to cover a few important topics. Infrastructure management. Yesterday. How we managed our infrastructure before. What did we do if we need more servers? Well, in some cases it could have been writing a mail, and I don't mean email. I can mean directly the mail, or just call your hosting provider. Or maybe in some good scenarios you had a web interface, so you was able to order a new server via that. And basically, a first option you needed to have your own data center and people installing and configuring hardware and pulling wires, literally. Another option would be to buy or rent or collocate servers from hosting companies. And in any case, process is slow and complex. And what are the main disadvantages of this traditional approach? That's first, it's always slow. I don't mean your servers are slow, they may be very fast, but the deployment and installation of the new machines are very slow. They are also very not flexible. Today you have a Black Friday, or literally last Friday was a Black Friday, is it correct?
Last
Yeah, last
Friday.
Friday. And you need,
Yes,
yeah,
in the
in
US
the
at
US
least.
at least, yeah.
Here in France, we just locked down, so Black Friday will be this week, this Friday.
Okay. And on Black Friday, you need to have much more computational power than in the normal day. And there are also days when everything is quiet and people aren't buying too much. And then it means, or you don't have enough computational power on a Black Friday, or you are overpowered the rest of the year and you are paying for idling servers, which is not nice as well. So that's definitely not flexible and slow to deploy and slow to change infrastructure. And when something happened, approximately 10 years ago, and one of the chief officers of Oracle called it cloud computing complete gibberish. It was something like that, but well, he was wrong. And now we speak about cloud computing as, like, only one of the cloud computing platforms, AWS, brought already into life 77 data centers, or better to call availability zones, and are building at this moment 15 more. And that's not count even like companies like Google Cloud Platform or Microsoft Azure. So altogether, amount of efforts into this cloud computing thing is huge. And what are the main features of the cloud computing? How we can decide if this provider delivers cloud computing and this one does not? Idea is very simple. First one, it should be completely on-demand self-service. You shouldn't wait for a manager or employee of Hetzner, for example, to get back from vacation or, I don't know, day off to process your query. It should be available on demand immediately and completely self-service. You shouldn't write any mails. You shouldn't make any calls. Just push the button, get it. Very simple. Second feature is rapid elasticity. If today you need 5 servers, that's fine. If tomorrow you need 500 servers, that's still fine. For our workshops, we are using cloud computing, and recently we did workshop about Cassandra, running Cassandra on Kubernetes, new project at the KubeCon. And KubeCon is one of the main projects and main conferences in everything what relates to Kubernetes. And we needed one day before, we needed 0 instances, well, maybe a couple of them to test the things up. And on the day of the KubeCon workshop, we needed around 1000. And next day, we needed again 0. So very rapid elasticity. I push the button, I get my nodes immediately, as much as I want. Well, there are some limitations, but still, it should be quick and very scalable. Resource pooling, or easier to explain, shared resources. You share resources with others. It gives you some advantages. It gives you first advantage of lesser price because you share your resources in most of the cases. It may be also not convenient in some cases when you require a completely dedicated hardware for you. Well, it's also usually possible. API programmable access. It's not a thing, it's not a cloud computing services that doesn't provide API, and we will talk about API a lot today because API is one of the essentials for infrastructure as a code. And last one, which is not interesting too much for us right now, but in general very important. Pay as you go. You don't sign a contract for 10 years of usage for the server. You just run one and you start to use that. And if you don't need it, you dispose it and you are done. There are some discounts in the modern cloud providers, but that's not the main thing for us for today. So, how do we manage infrastructure today? It works very differently. Infrastructure management today more and more involves API. Instead of manually pushing a server into a rack, we simply make an HTTP API call to get a server we need. Meanwhile, software-defined networks changed really a lot and simplified networking so much. We pull less wires, or usually we don't at all running with cloud, so that's not our job. That's the job of our cloud provider. In short, today we still use web interfaces, but also API calls to get what we need. Okay, I'm talking about clouds, how it was before, how it works now. But I still feel the question here. Alex, what is infrastructure as a code? And, well, maybe for some of you I will have a little bit of surprise. Have you ever used Docker and Docker Compose? I'm curious if we have any answers in the YouTube chat, because I bet what significant amount of our viewers happen to use those technologies already. Yes, 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 perfect. Okay, so you use it, Docker and Docker Compose, and you're already using infrastructure as a code. And that's not a joke. That's a little bit another layer of infrastructure as a code. Not we usually run with things like Terraform or CloudFormation, but that's exactly the idea of infrastructure as a code. Take a look. At first we have Docker and Docker Compose. Docker client calls API methods provided by Docker daemon via HTTP calls, correct? So you have client, you have Docker daemon on your local machine or somewhere in the cloud, and you make a command docker run, open port, run, for example, nginx. That's a system call to Docker client and then an HTTP call to Docker server. And now comes Docker Compose. Docker Compose reads configuration file and run proper Docker commands. And Docker Compose up. By this command, Docker Compose will read the file and execute proper run commands for you. And notice, it's declarative, not imperative. In the Docker Compose, you don't explain to Docker or Docker Compose what to do or how to do. You just explain what I want to have. I want to have this service, that service, and this database, and this port open, and this command executed, but you don't care exactly how it executes this command. And that's very important. There are two kinds of approaches. Imperative, you tell explicitly what to do. Do this, do that, do this, do that. Open port, run a command, run the next command. Or declarative, you just explain what state you want to have in the end. And that's these orange or red maybe on your display lines are very important. That's what makes out of the infrastructure as a code. So what's that in the end? Infrastructure as a file? And basically, yes. Basically, infrastructure as a code is infrastructure as a configuration file, which you describe what you want to have. Usually, there are some declarative tools, there are some imperative tools as well, but we will speak about Terraform, which is declarative. And I say here, I need my pointer. So we are going to have some volumes, We are going to have some services, we are going to have a database, we will need some environment variable, we need some ports open, and so on and so forth. Don't focus on this example so much. So far, that's just the explanation. Infrastructure as a code means you describe your infrastructure in a configuration file, in a special configuration file. In this case, that's a Docker Compose YAML file. And what happens then when we have infrastructure describe it in a file? There is a tool doing API calls for us. So that's Docker Compose asking Docker to execute those statements. If we speak about the first example, Docker to Docker Compose, target service must provide an API. As long as you have an API and the client to access it, it already sounds good. A good example for us will be an AWS CLI tool. If you happen to work with AWS, you know what I mean. If you don't, explanation is very simple. AWS CLI is a very simple console program you can run on your own machine and give the commands, and it will make API calls and ask AWS to do some job for you. Create a server, terminate a server, and many other things. Notice it's an HTTP interface, so you could run the same commands via curl or any other HTTP-based client. And as we have Docker Compose working with Docker Compose YAML files and making HTTP API calls via Docker, we have the same story, and we need the same story for infrastructure as a code, the pure infrastructure as a code approach. There are multiple tools. We can separate them into first two big groups: vendor specific or multi-cloud support. I don't want to call them vendor agnostic because it wouldn't be completely correct, and you will see why in the end. But for now, we know what AWS has CloudFormation, what Google Compute Platform has Deployment Manager, and Azure has its own specific tools. And they are dedicated and they are doing their job very well working with those clouds. And on another side, we have multiple cloud support tools like HashiCorp, Terraform, Pulumi, and SaltStack, and many others. I don't want to put all the logos here. But if you're curious about the multiple cloud support, that's like for today, I guess around 95% of the cases will be Terraform. Ours are only trying to catch. Another grouping we can make here is imperative versus declarative. Again, in imperative, you tell explicitly what to do. And with declarative, you explain what do you want to have in the end. That's a different approach, and personally, I'm much more on the declarative style you will see today in Terraform. Well then, Terraform is an open source infrastructure as a code software tool created by HashiCorp. Users define and provision data center infrastructure using a declarative configuration language known as HashiCorp Configuration Language, or HCL. This project exists for like 6 years. It's a very big project with like 25,000 stars on GitHub or something like that. It supports nearly every main cloud provider, or not only cloud provider, you may imagine. So all the AWS, Azure, Google Cloud, OpenStack, Oracle, whatever, IBM Cloud, and so on. But at the different state, let's say, because for the main providers, they have full support. And for the outsourced, for the not so popular clouds, support may be a little bit outdated. By the way, speaking of vendor specific or multiple cloud, usually people say I don't want to be vendor specific, I prefer to be vendor agnostic because, well, what if I decide to migrate at some point? In this case, it comes with a little price. When you use vendor-specific thing like Google Cloud Deployment Manager, whatever Google Cloud adds, it will be immediately added. I mean, new feature, new service, and so on. It will be immediately supported by Deployment Manager. And when you work with other not native services, then it may take some time before support for my new services will be delivered. But you know what? It's an open source. You want to get it, you go and develop that. So, well then, it all starts with a configuration file. How does that work? We have a sample Terraform file on the right side. And of course, we have to define some resources we are going to use. At first, that's how a HCL HashiCorp configuration language looks like. A little bit of YAML-like, but also with some inclusions here and bit more features you will see in the end. And on this file, we define 3 resources for us to go. We will work with a little bit more today. First one is going to be security group. You know, I don't know your experience with AWS. In short, we can call security groups as firewall rules. So, in this case, on the last example, I create an AWS instance, call it voting. You will see why in the moment. And I define 2 security groups for that. Those security groups will allow port 22, so SSH connections, and port 80, so HTTP connections to these nodes. So at first I define AWS security group SSH with the name allow SSH, and it will be an ingress from port 22 to port 22. It allows to define ranges, but I don't want to use range in this case. With protocol TCP, allow it from everywhere. And basically the same with AWS security group for HTTP. It looks very familiar, but it opens port 80. That's the only difference. Within the security group, you may have multiple rules, but for us, for the to stay clear, I prefer to have 2 different groups here. And then, downstairs we have AWS instance. Finally, we are getting to something interesting. People usually not interested in the security groups. Let's take a look. That's AWS instance. So that's the type of resource we create, natively supported by Terraform. It's going to be AWS instance, pretty obvious. Then its name, notice that's a name in the Terraform system. That's not what goes to AWS. That's a name, like a name of a variable, because we need to reuse some values, you will see, available for other resources in Terraform. It will use AMI. That's actually replaced one already, but doesn't matter. If you aren't so much into AMI, when we create an instance, we have to specify the base image. And AMI is Amazon machine image, so that's the template for the machine, not exactly the template, but the base image we will use to spawn this machine. Instance type T2 micro. I don't need a powerful machine for this example. And when it has some security groups, and now take a look, I'm specifying security groups like that. Actually, now this type is changed, so we will write it in another way during the practice steps. And I'm specifying AWS security group SSH name, and I'm also specifying AWS security group HTTP name. What are those HTTP and SSH? Those are the names of resources I've just defined, and those type is AWS security group, AWS security group. So now you see I can reference them, and I'm arranging those security groups to this instance. And now notice, they may not exist at all in the AWS in the moment when I will ask Terraform to apply this file. That doesn't matter. They will be dynamically created, and their IDs or names in this case will be put into the required security groups for my AWS instance. And that's how it works. And then next thing, I'm using a resource key, which will be AWS key pair deployer key name. You don't see a resource definition for AWS key pair here, but you already know what's going on. That's going to be a resource type, AWS key pair. Its name will be deployer, and I need to put a key name to the key name property of this AWS instance to have it available. Well then, we have to specify connection details because we are going to change something on this machine after it will be launched. And now take a look. That's important. I have a special slide about that because people mix them all the time. But that's a very important notice, so it never hurts to repeat twice. Infrastructure as a code tools like Terraform are not provisioning tools. They are to define your infrastructure, virtual machines, networks, S3 buckets, and many others. But if you need to have a complex provisioning, like install some software, install some dependencies, do some preparation steps, and so on and so forth, it's very much recommended to use configuration management tools like Ansible, Chef, Puppet, and many others, whatever you prefer. So just once again, in the provisioning part, you should use as small lines as possible, preferably 0. And if you don't have anything to provision, if it's all done by Chef or Ansible, that's not part of this workshop, of course, then you can completely remove connection and provisioning part. But in our case, I specify connection, I tell which user to use, and I specify a provisioner remote exec, so I will do a remote exec to contact this node via SSH using the connection data. I specify right here and run a command. Which command? To simplify the things, we will not install any packages, but simply do docker run detached port 80 voting application. That's a part of application we are going to use today. Is that enough? We have security groups, we have instance, we have defined a key pair, although it's out of the scope of this file, we will open it. I see a question, what does it mean by core in the connection? It's a username, so in the connection we define, you will see it in a moment on the practical step. In the connection, we specify the connection details, user, password, or maybe key, and which host to use, and so on.
Yeah, they are using their own language, what they call the configuration language. It could have been some YAML files, right? Doing a lot of Kubernetes, you find the same terms. What is a resource? You find some ingress rules for opening ports. Yeah, they could have used YAML.
So there, of course, there is a lot of arguings about this, if they should have used YAML or not. Personally, I'm always on the YAML side. But you know what? It's always easy to judge as long as you aren't in the core team. And well, Terraform is a very complicated project working with a couple of dozens of different clouds and supporting pretty complicated workflows.
Oh yeah, no challenging. Just it shows their own, their own. Maybe they were there before Kubernetes became a thing. So makes sense.
Yeah. So yeah, in general, I would also support. I would prefer YAML when HCL, but that's not the option we can decide. I see the question by Mones Boulel. What about VPC, Virtual Private Cloud, and Subnet? Yes, they are completely definable via Terraform. So we start small and we can, I don't know, take a look at some of the examples. If we go to Terraform configuration file, Terraform AWS API. No, not gateway, but doesn't matter. And I need docs. Not registry, but it may work as well. So I have a very really a lot of the AWS things supported. and that's registry, but I need docs, actually, Terraform. So if you go to the documentation, docs home, and we will find proper registries. So we have to open AWS, for example. You can see what you can define nearly everything what exists in AWS, at least in EC2, 100% everything you can describe with Terraform. Well then, few commands we have to consider before going on. First one is Terraform init. We use Terraform init to initialize a project. That's like git init. That's basically the same idea. Terraform will analyze the project files, pull proper modules. As Terraform supports so many different clouds and so many different services, it makes sense to not download the whole Terraform at once, because it's just going to be too big, but just download proper modules you are going to use. When you can use a Terraform plan to compute the changes you are going to apply, we will see it in a moment, and then Terraform apply will apply your changes. And if you done with your training, you can go with Terraform destroy to wipe out the whole workspace. But in general, all changes usually done with just changing Terraform configuration files. And I guess that's time for me to switch to terminal, because I guess terminal is the thing you like the most.
Yeah.
Good. So I have it right here, and we are going to clean and make it a little, oops. I'm going to clean, clear, my god. And make it a little bit bigger, and make it full screen maybe. Good, boom. Clear, boom, and again a little bit bigger. So looks good. Yeah, talk is cheap. Show me the code. So that's a Terraform it repo, pretty small one. Some configuration files. By the way, I have to remove plan 1. Good. And I think I will move myself closer to Cedric, so I will not hide code like that. So I will not hide the code from you. Well, yeah, like that. I think it will be fine. Good. So what's in these files? We can take a look. There is my code. Boom. So I will close some of the files, and we can discuss what's important for us and what's not so important. So the main, you will have access to this repo after the workshop. Meanwhile, let's take a look at the things what's going on. We may have everything in one single Terraform file. It's fine as long as you may want to have a couple of instances, couple of networks, some databases, and that's it. But actually, the thing you want to have is usually you want to put them into the multiple files, and that's what done in this case. We have AWS config to describe the main configuration for the AWS cloud. But so we have here definition for the provider. We have, do you remember from the example, AWS key pair deployer, and this one present here. And we also have definition for the security groups, a little bit more now. So we have SSH for the SSH shell connections. We have HTTP. We have Postgres for the Postgres. Redis for the Redis. And outgoing is a simple egress, so not ingress, but outgoing connection to allow our nodes to make get update and other things they may need, so we will be able to reach external servers. But also, as we are speaking about multi-cloud things and Terraform supports multi-cloud, I have a do config, which is going to be pretty easier and not so powerful as as AWS, but well, much easier to use and one of the clouds supported by Terraform. In this case, we define only access tokens as soon as it's described in AWS instances, and also not instances, sorry, AWS config. And that's so we define the provider type of a provider. And for do config, yes, we define this DigitalOcean. And we define also SSH key, as that's the same as a key pair. For the main connection we will use for a DigitalOcean nodes. Now here is a question. Why do I don't call why don't I call Terraform vendor agnostic? Answer is simple. Take a look. When we speak about Apache Cassandra, I can run Apache Cassandra in every cloud provider I have, and I don't care if it's so much, if it's one or another, if it's AWS or on-premises. It runs the same way. I just can run it and I don't care. But with Terraform, it's different, and I need to use different ways to describe my instances, for example. So take a look. In this case, I have resource AWS instance, name it Redis. It will use an AMI, it will be instance type T2 micro, it's enough for the demo purposes. It has some security groups and key name, and it has some connection details. You may take a look. It looks now different. It's changed with Terraform version 0.13. So I'm specifying user, host, and private key to connect. And also some provisioning, which should be familiar to you already. And point here is, when we go to DO instances, it will look differently. So instead, as AWS uses AWS instances, and Terraform uses AWS instances, therefore, for DigitalOcean, they use thing called droplets, which is basically the same, but has a little bit different API, a little bit different name, and so on and so forth. So what does that mean for us? Oops, sorry. I want to jump back. Yep. Good. It's not exactly vendor agnostic, because you still need to understand your vendor API, and you cannot define one general node and then tell Terraform put 3 items to AWS and put 5 items of that to Google Cloud, for example. You cannot do things like that. You still have to explicitly decide and explicitly describe what exactly you want to have. So DigitalOcean droplet will looks differently. We don't define AMI, but we define image. Idea is the same, but name is different and API is different. And here we specify size explicitly instead of specifying instance type as with AWS. So can you work with multiple clouds at once using Terraform? Yes, you can. Is that vendor agnostic? I wouldn't call that vendor agnostic. Good. So, okay, let's make a deeper dive into the AWS part of the instance first. I see a question. Why are some asking public key and some private key? That's very simple. When we specify a public key here, so that's basically where we specify public key. It will be put into this instance by AWS, ask it from Terraform. So this instance, AWS instance Redis, will have public part of this case. But here, to connect from my host to this host to make a provisioning, I have to specify the private part of the key to execute this kind of a provisioning. Again, try to avoid provisioning with methods like that. Or if you absolutely have to, at least try to do it very, very, very small. Again, when we provision almost 1,000 servers at once, and pretty big servers for our workshop at the KubeCon this month, that takes a long time by itself, because you are going to create 800 nodes, approximately 2,000 and something domain names, well, subdomains, but still, and some security groups and others, so it takes a lot. But when you also have to wait for the provisioner remote exec to execute provisioning, it may take literally ages, and that's not consistent. You cannot replay provisioning here, it's executed only once. Terraform is not for provisioning. So I would say what the maximum thing you can do here is to install Puppet client or things like that. So install configuration manager client to do the things, to follow the things like that. And then finally, the best case scenario, if you can create your own AMI, which already has all the base configurations, then set tags, so it will be provisioned by Chef, Puppet, Ansible, or any other configuration management tool as soon as it will be ready. So, are there any more things to notice? Yes. So, at first we speak about AWS instance Redis, and we covered the main things here. Here is very similar AWS instance called dbeam, but it has another provisioning command. So as a part of this command, we will run PostgreSQL. When we have AWS instance called voting, again very similar, they are different only on what we are doing. But here comes again interesting thing. Take a look. There is again a reference we have to cover. And I see a discussion in the chat: is Terraform is vendor agnostic or not? And you see that's word question. Some people will call it vendor agnostic. You can work with multiple databases, or you can work with multiple clouds, then it's okay, it's agnostic. Some people say it's not agnostic, because yes, you can work with multiple services, but the definitions will be different, and you cannot copy-paste AWS definition file, put it into the Google Cloud part, and apply that. It will not be executed as a Google Cloud commands. So some people think it's called vendor agnostic, some don't. I don't want to participate in a holy war on the terminology here. It's boring. We better go and deploy some things, okay? But still, there is one thing I want to mention. This application, voting application, it's a front-end application for the system we will deploy today. And to work, it's as it a front-end, it's need a back-end to put some data into that, of course. So in this case, we define an environment variable, Redis host, and take a look what we are getting here. It's going to be AWS instance Redis private IP. And that's not exactly an environment variable on this host. Nope, it will be first handled at the Terraform level, and it will know what we have to put here, and property of AWS instance, call it Redis, property call it private IP. And if we go to AWS instance Redis, define it above, we don't see any kind of a private IP here, because we don't define it explicitly, but it will be calculated. So at the moment this instance will be created, we will also define this Terraform will define this private IP for us, and we'll put it here. And then after the Redis node, voting node will be created. And notice that's an obvious dependency. We cannot create voting node before creating Redis node, of course, because we have to provision that, and we don't know private IP of AWS instance, and therefore we cannot start that. This dependency is automatically handled by Terraform, so you don't have to wait, or you don't have to manage this dependency graph anyhow on your own. It's managed by the Terraform, which is great. So some more things. AWS Instance Worker. Worker is a little Java application which processes results of voting, takes them from the Redis and puts them into Postgres already processed. So in this case we need to have two hosts, but these statements should be very familiar to you. We simply define environment variables for the Redis host and database host. And we will run a Docker image called worker. And finally, AWS instance result. That's another one front-end application. Front-end for the final results. So voting is the one where you push button and you vote. And result is the one where you see the results. It's a distributed application, as you see. And again, it's the same idea. This one needs the connection to a database host, which I define like that. Notice what if I use resources directly, I don't have to put any characters like that, but I simply write I need a key name, and key name will be AWS key pair deployer key name. And in this case, I have to do an interpolation because I need this reference, this private IP, has to be a part of a string which will be executed on the remote host. And the idea is very simple. I use this interpolation here. So the property I need to put is put like that. And then finally, that's not enough for us. You know, those for the AWS instances, if you have some experience with that, you already know what I mean. Normal IP for your nodes, they are ephemeral. It means what you may get them. You may get one IP, but after restart, you will have another IP. So you cannot rely on them. They may change from time to time. And for some of the databases, for some of the services, applications, for the backend parts, I don't care about that too much. But imagine how not convenient if it would be if front-end IP of my application would change from time to time, and when I have to go to domain name service and change something there. And that doesn't look nice, of course, because I have to do things like that, and that looks like a downtime. Although application runs, it's not available. So to solve this problem, with AWS, we use elastic IP addresses. And in this case, we are creating them very simple. I create an AWS elastic IP address. I call it voting IP. And as an instance to map, I specify it here, AWS instance voting ID. And what's that? AWS instance voting ID. I guess you know already. AWS, it's a type, voting, it's a name, and ID is a property we are going to get. Let's take a look. That's our instance, AWS instance, voting, and ID is not defined yet. It will be calculated. So, and I define 3 elastic IPs here, voting IP, database IP, and result IP. So they will be available, and those instances will be mapped to these IPs. And even if instance is restarted or whatever happens, it was downtime and now it's running again, it will have the same IP address. So I think that's enough for us about the files, and now finally let's put some action here. So I hope you can see my screen. If you don't, then let us know, so we will make it a little bit bigger, but I think it should be good. So,
yeah, I think it's
yeah,
good.
looks good to me. So first command you need to learn is Terraform init. It will prepare the project. And in my case, it runs pretty quickly because I did the init already. But let's take a look what exactly happening. So it will initialize this part. First, it installs providers. Again, there are very many providers. Why should you install a GCP if you aren't using GCP? Makes no sense. So for me, I installed it already. We are installing HashiCorp AWS, and we are installing DigitalOcean. Very well. So latest version was installed. We don't have any constraints on that. And it also warns us to prevent automatic upgrades to new major versions, what may contain breaking changes. We recommend adding version constraints in a required providers block in your configuration. What does that mean? Oh, I see a great question. Terraform should be used for EAS only or EIC only or managed services too. Yes, you can use infrastructure as a code with Terraform to run managed services. Take a look. The general idea, file definition and API calls. If something you are going to use has API calls, and you can describe it into a file, then Terraform is a great thing to map them together. So you want to have a managed service by AWS or Google Compute Platform. Mostly probably you already have a model to do this setting. If it not exist, well, you can develop it on your own. It's still open source. For example, now DataStax delivers Astra, which is a Cassandra as a service. Cassandra is a great database, but it brings also a lot of... it's not the easiest one to run from the maintenance and operations point of view. I see some pain in Cedric's face because he knows that very well.
I do.
Yeah. So, and Astra as a Cassandra as a service, you don't deploy it. You simply use that, go to astra.datastax.com and use Cassandra as a service managed by DataStax. And our next step will be to deliver AWS module, Terraform module for Terraform to support astra.datastax.com. So you will define in the Terraform resource definitions our provider, so DataStax, and which particular Cassandra setup you need. And Terraform will do API calls. We already provide API, of course. And boom, you have your Astra deployed exactly as infrastructure as a code. Astra was released some months ago, so we don't have yet Terraform module, but I believe we are going to have it pretty soon. Okay, from where plugins will be installed? It's called, I believe it's called registry. Terraform registry. Yeah, here we go. So Terraform registry is the main registry to deliver all the kind of models you have. So you may have a lot of providers. 574 providers. Oh my god. And 4,541 models. And if we speak about providers, it's going to be a list like that: AWS, Azure, GCP, Kubernetes, Oracle Cloud, Alibaba Cloud, Active Directory, Console DNS, and so on and so forth. And that's not all of them actually, but some more. For example, I know some domain name services provide their own API and modules, so you can manage your domain names also with Terraform. That's what we do for our workshops. If you attended one of our workshops before, you maybe have seen notes like Workstation X, datastaxtraining.com, and that's a domain name, sometimes multiple names, and an instance behind that. They're all completely provisioned by Terraform. And if we speak about models, that's also going to be a pretty big list. So that's a question about how do we care about virtual private clouds on AWS. So here we go. Terraform AWS module virtual private cloud, which supports all you need to do with virtual private clouds. I guess there should be Oh, a module managed by Anton Babenko. I know this guy. He is great. And you may have, you may see what kind of resources supported and what to do with that and so on. Okay, but let's move on, and we are going to do some things. We mentioned it here. What it's recommended to set version constraints in a required providers block in your configuration. So what's the required providers block in my configuration? I haven't shown you this file yet, but I'm to do it right now. We have here versions Terraform file, and it's a very simple file which declares everything what we need for Terraform to run. First, it requires which version of a Terraform we are going to run. That's important to know what Terraform API changed over the time. So version 0.12 will behave a little bit differently when 0.13, and before this file and this configuration wasn't required at all. Now we need to have that, and we specify required version for Terraform 0.13, and for required providers we specify AWS with the source HashiCorp AWS, and for DigitalOcean source DigitalOcean. By the way, as you could guess, we can find it completely here in the providers. Okay, so here we go. That's our provider. Well then, so finally, let's run some commands. Stop watching files. Let's do some commands. I already did Terraform init. That's an important command, but that's not enough. We only initialized our backend. What we want to have here is Terraform plan. Plan you can compare with a dry run command you have in some tools. Plan helps you to understand what's going on to change after we run this command. It doesn't do anything but calculate changes it can calculate without doing any changes. And we see that's a nice output. Plan 15 to add, 0 to change, 0 to destroy. It means what we have no kind of those resources in my cloud, and they all are going to be created. But what kind of resources we are going to create? Okay, this one should look pretty familiar to you, at least an AWS part. We reviewed it already. Terraform plan, refreshing Terraform state in memory prior to plan. Refreshed state will be used to calculate this plan but will not be persisted to local or remote storage. What does that mean? Very simple. Take a look. Now we are working with two providers, Terraform AWS and Terraform DigitalOcean. And both accounts are empty because those are my tiny accounts and there are no nodes running right now. Or maybe a couple of them. Doesn't matter. We have to calculate the changes. It means what we need to have, what we have in file and what we have in the cloud. And if we will try to do it directly on the huge infrastructures with thousands of servers, it may take ages. So there is a little sync Terraform state which shows like this: Terraform tf state and files in the Terraform folder which describe things we have for in the cloud already to avoid additional operations. So we updated local state, our local understanding of cloud deployment. Execution plan has been created and shown below. Resource actions are indicated with the following symbols: create. Only create, because we will not modify, neither delete anything. And at first, we are going to create elastic IPs, first, second, third, sorry. And technically, they are going to know a lot of we are going to have a lot of properties What will be public IP of this elastic IP? What will be public DNS of this elastic IP? But it cannot be calculated right now because you know that only then you ask AWS to create them. So they aren't reachable at this moment. And then we can see what instances we are going to create. We know AMI. Why? Because it was defined in a configuration file. But we don't know, for example, ID, because this instance doesn't exist and AWS is not yet asked to create it. Therefore, we know no ID. The same for instance type. Instance type is defined. We have security group names, and it will has default elastic block, EBS block device. So let's say disk. Some other properties for us aren't so important. So AWS instance radius, it's mostly the same. I don't want to stop for them for too long. AWS instance result looks mostly the same, only comment is different. Okay, and it should be okay. Worker is important for us as well. Then that's the AWS key pair deployer will be created. That's the public part of my SSH key, which will be uploaded automatically by Terraform to AWS. And all of those nodes above will have this AWS key pair and this public key injected by AWS. Some security groups, we have discussed them already. So they are here. And some DigitalOcean SSH key, which is part for the second step. I don't know if we will have time to do the second step today. But when you can do it completely on your own, and I will help you at Discord. So don't worry. So we are planning 15 to add, 0 to change, 0 to destroy. And before I do Terraform apply, there is a little warning you should notice. Take a look. You didn't specify an out parameter to save this plan. So Terraform cannot guarantee what exactly those changes, those actions will be performed if Terraform apply is subsequently run. What does that mean? It's a little bit funny. Take a look. I did this Terraform plan some minutes ago, maybe 5 minutes or about that. And what happened meanwhile? I'm talking to you. I don't change anything. That's my private computer, my private laptop. No one changes here anything. But that's also a problem possible what you are working not alone on the environment where you have multiple people working with you together. And someone started to put changes into the Terraform definition files. And you don't know about that. And they are not ready. And they may hurt your infrastructure anyhow because they are not finished yet. And if I run now Terraform apply right now, in my particular case, I know what will be executed. 15 to add, 0 to change, 0 to destroy. But if you are trying to do the same on the computer where multiple people may have access, your result may be completely unpredictable. So in general, what do you want to do is Terraform plan specifying an out command and give the name of a file. Let it be like plan2 or whatever. You can play a plan and specify the time. And in this case, Terraform plan will be also stored in this file. And now this plan was saved to plan2, and now I can apply this particular plan. So I can say Terraform apply plan2. So in my case, there will be no difference if I just Terraform apply or Terraform apply plan2. That doesn't matter. But on production, you definitely want to understand the differences and maybe save your scheduled plans. So I'm going to push the button. Yep. So it recalculates plan because I didn't specify it plan2. And now it asks me to confirm this action because I didn't use auto approve method. I see a good question. Do people test their Terraform script? If yes, how? So take a look. One of the best features of Terraform is, or infrastructure as a code in general, is reproducibility. Basically, you can run Terraform apply with some set of files using some dedicated place, not the production infrastructure, but staging infrastructure, and see what you have as a result. You can replay the same files on multiple different places and see that. So, okay, sorry, I have to switch to the file was going on. So in general, yes, people do it with TerraTest, which is also, I've heard, was heavily contributed by Anton Babenko, we mentioned recently. So what's going on right now? We are going to create some things. We are creating first key pairs because they don't have any dependencies. Everything uses them, but they don't depend on anything. So they are the first one to be created. When we are creating security groups, meanwhile, by default, if I remember it correctly, Terraform executes everything in 10 parallel sessions. You can configure it to be slower and faster. In my case, for DataStax trainings, I'm using parallelism of 40 at once. It works well for us, but for your mileage may vary. So we're creating seg groups. I don't understand what's happening with my screen because it's jumping. Okay, it looks good. And I know that's a lot of output from remote provisioner. That's why it's jumping. Okay, and we see what key pair creation complete after 0 seconds. Key pair was created immediately. Security group creation complete after 1 second, after 2 seconds. So that's pretty good. For me, was a huge surprise what AWS Route 53 works pretty slow. So for us, biggest job for our big workshops like at the KubeCon, I mentioned third time today already, we can create multiple hundreds of servers within a very short time, and when we wait for dozens of minutes for the resource records to be created. It looks like it's much easier job to create a DNS subdomain than to create an AWS EC2 node. But funny enough, EC2 node creation works much faster than Route 53, at least for us. That's incredible. But okay, as long as all the blockers have been created, so we have key pair, we have groups, and so on, we can go and create instances. And here we go with instance DB and instance Redis, and we start to create them. As soon as they are created, remote exec provisioner tries to provision them. And of course that doesn't work because they are kinda created from the API point of view, but they aren't started yet. So it will take some time before remote exec will be able to connect to remote host. Okay, and finally we see what Redis was able to connect. We were able to connect to Redis, and that means what we are executing our remote provisioner command, and it was to run a Redis database, and this image is not yet on the AMI, so it will be pulled. And the same meanwhile happens on the Postgres, which is called a DB in this case. And it does all the job required to pull the proper images. Pull complete, I see, for the DB, and extracting starts. Oh my god, that's pretty a lot. Good, pull complete. So creation complete for DB. And you see, depending on our graph of the dependencies, now we can to proceed to elastic IPs because node has been created, and now we know ID of a node, so we can allocate an elastic IP for this node. Therefore, we can create an elastic IP and we can create other nodes. Result and worker needed to know their IPs. You remember? And that's again managed. Now we have those IPs, therefore we will use those. We can create now result and worker nodes. Question. If an error occurs in provisioning one instance, for example, the whole process of a provisioning will be discarded? In short, no. So, there is no rollback. Indeed, Cedric is absolutely correct. There is no rollback. And if provisioning failed, you will get a warning in the logs, but all the other operations will try to execute. And again, there are no attempts to retry and many things like that. Nope. Terraform is not a configuration management tool. So you may want to have something better for configuration management. Ansible, Chef, Puppet, SaltStack, and many others you may want to have. Okay, so now the same job happens with our voting and result and worker instances. Connected. So we're unable to find proper images locally. We will pull Docker images. In my case, notice what I'm using AMI with pre-configured Docker. So we are missing Docker images, but I don't have to install Docker. I directly go and do Docker run command. So extracting, pull complete, extracting. Pretty a lot of things to do. And we must be done. Perfect. And okay, as soon as they are done, creation complete for Elastic IP and creation complete for AWS Instance Worker. And most of this time was taken by provisioning. Try to avoid provisioning when possible. So, apply complete. Resources are 15 added, 0 changed, 0 destroyed. Looks pretty good. Yes, exactly. Mani Sarkar says, I see where Ansible fits in, where Terraform does not provide functionality. Exactly. So, tool separation, you better have one tool per purpose, which will work good. I want to have a hammer and I want to have a screwdriver, but I don't want to have them combined. And we have a lot of great configuration management tools. Those are perfect to run together with Terraform, but I'm very happy they're not trying to replace provisioning and configuration management tools. So let's take a look. Yep, granular tools, very agree. So let's take a look on how it goes. Hopefully have here everything what I need, and I to update that and make it a little bit bigger. So I wanted to have 5 nodes. I have 6, so one of my old runs. Oh yeah, that's old one, doesn't matter. And those are my new heroes. And those 5 are exactly the ecosystem what I created. And if I go to Elastic IPs, I can find the Elastic IPs I allocated for them. So, for example, we see what this public IP was allocated to a node. Allocation ID, allocated instance ID was allocated to that node. But I'm not about the nodes right now because I want to open those IP addresses and check if it all was deployed in the end. We did such an incredible job today, so now I want to see how it all works. Good. So, okay. Okay, looks not so good to me. Give me a moment. Okay, so it tries to start, which is already good. Cats versus dogs. Oh yeah, finally. Results somehow not available. I'm curious why. So, I told you the application we are to deploy today, is the very simple one by idea. You can participate in the voting, and I even can copy paste this IP address to you. And you can vote between cats or dogs. I'm a bit curious. Okay, it works to me. And you can change your vote, so you can vote for the next one. And I'm trying to open the results. So it should be this one, I guess. Number 18. Okay, something goes wrong with my results. I have to check, but in general, that's one of the parts of this 5-component application which was deployed and available right now. And I guess you can reach that using this IP address as well. Well, then. Good question. Can we use effectively infrastructure as a code with the help of a Terraform over already exist environment? So that's a complicated question. If you already have environment running, you can try to import that into Terraform. So you set up a provider and so on. You ask Terraform to import. It will try to analyze the existing infrastructure and pull it. But the problem is, at least for me, it never worked good enough. So for my case, the first, in my experience, for the projects I was using Terraform and responsible for the Terraform, we first started to use Terraform for staging purposes, test purposes, not for production, and went smoothly, part by part, we migrated production to Terraform as well. But import didn't work for us too good. You see, it was some years ago for DataStax trainings. I was doing it from scratch, so there were nothing to import. And on my last project, I tried to do it 4 years ago. So, like, you see, it was which year was Terraform created? We recently discussed it in the slides. Oops. Yeah, active since 2014. So 4 years ago, it was only 2 years old. Pretty young project, so maybe now import will work better. Again, more popular, more in-demand project you are using, higher your chances what modules will be well developed. If you are using something what is not so popular at this moment, like many years ago we were working with OpenStack, it was a very sad story. Terraform support for OpenStack was just very, very weak. But for AWS it was good. So for us it ended up we were not happy with OpenStack and we moved to AWS in the end. And I don't mean DataStax, it was on my previous project. And it went pretty smooth in the end, but yeah, it wasn't so simple. And I do understand what you mean regarding the already existing development. Oops. So yes, maybe it's problem with the server before they were completely enough. That's why I'm so surprised. I can try to check the logs, but I don't want to waste your time on that. But in general, we can spend a minute on that. So I have those instances running. and we know what frontend works. We know what frontend was this 33.144 node, and we can find an elastic IP which has this 144. Perfect. And we can find an associate instance, and I can log into this node. Why? Because it uses the IP address I gave, not IP address, sorry, the key I gave. So I'm going to copy paste this address. Doesn't matter very well. Boom. Copy. And I can go with SSH EC2 user and give this IP. Yes, I have my private key installed, so I can jump in. I can say docker ps, and I see my application running. It says up 2 hours, which is very weird because it shouldn't be up for 2 hours. So maybe some UTC difference, and I can say docker logs -f 097. Okay, so on this side it looks good, and we can jump to another one. So we have some instances here. Boom, 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 boom. 65. Boom. Okay, that explains a lot. So we basically have nothing running on these instance, and I guess docker ps-a, one of the commands failed. It was Postgres, and that explains everything. We don't have Postgres running, that's why it cannot work. And I can take a look at the logs, what exactly went wrong. Docker logs -f post stop 21f, that will be enough. Okay, so values changed, and now I have to always specify Postgres root password or Postgres host auth method crust, which is fine. So as soon as I have it running here in my instances, it should be good again, because all other things are staying like before. So I need to have one more thing. I hope ours didn't failed. Okay, and this one hopefully going to be available over time. 944. Oops. Okay, so take a look. Something is happening. Something is happening here. What happened? That's a bit funny application. It's really tiny, it's really small, but it's really microservices oriented, working together very seamlessly. And the front end part, as soon as you vote, where is my browser? Yeah, as soon as you vote, it puts your task, your vote as a task into a Redis queue, and when worker is to process this queue, get the values out of that, and rework them a little bit. Well, that's a demo application, not really rework, and then put to Postgres, so they will be reachable by others. So it looks like now it should be better. I'm not sure if it should be this IP. No, not this one. So maybe this one. Oops. Come on. That was the wrong button. Sorry. So I'm missing this one. I hope that's our guy. And meanwhile, so yes, there is indeed voting goes on. on the Postgres, and it means I only have to check the result application. User will be the same because I'm using the same AMI. Oops, of course. No HTTP here, please. Okay, so we know what happened. Yes, result failed to start because PostgreSQL was not available. So we can try to start it again simply. I have the command here with me for the result application. Notice what order of resources in the file doesn't matter at all. Okay. $76 CAC. Yeah, given up. It was not able to connect to a database. Don't worry. Now you will be fine. And IP will be this one. Boom. Yeah, so what about the logs? C7A4. Boom. Okay, application is running on port 80, which is very nice. So I guess now we can contact. Oh yeah, it's here already, and cats are winning, but only a little. If we now all together will try to switch to dogs. Okay, I already did, so I will change my vote here and switch it back. If we now all switch to dogs for the testing purposes, we will see hopefully what dogs are winning. But I'm on a cat side, that's just for the testing purposes. And by the way, IP for the results is this one. So usually it updates automatically. Okay, no one votes, so you can change your vote. Okay, I will switch to cats. And it should be placed here immediately.
Vote, vote, vote.
Yeah. Okay. So, but in general, let's recap briefly what we did. Yeah, there is a little latency, it's fine. Let's take a look on what we did already. We prepare a Terraform configuration with the files. So that's basically all the files I wrote on my own character by character. Well, I copy pasted significant part of that, but in general, that's the main idea. We have Terraform, we have versions Terraform file to define which Terraform and which providers we are going to use. We have AWS config and DigitalOcean config to prepare the main things like key pairs or security groups. If you have a lot of security groups, you may completely use, for example, new file, AWS sec groups.tf. Boom. And I can simply cut them off from AWS config. Boom, 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 boom. It will look a little bit nicer. So I will have seg groups only with seg groups, not with key pairs or anything. And now take a look. I created a new Terraform file, AWS underscore seggroups-tf. And I can go here and say, hey, would you please hide? Yes. And I can completely say Terraform plan. And what will happen? Nothing will happen, because nothing to change. Yes, the same resources, different file allocation. Feel free to define the files as you would like to, but that's the main thing idea. Yeah, no changes. Infrastructure is up to date. And finally, what we have to do on that. We created multiple nodes. We allocated elastic IPs. We also can easily add resource records. So if I would go, for example, for my dear Mr. Jenkins, you may find also definitions like that. Is there anyone running right now? Okay, there are no one running right now, but well, we can then go for templates, and we can go for KubeCon, for example, KubeCon Workshop 2020. So this one was the base for KubeCon. It may look a little bit different because it's not the prepared Terraform file, but a groovy template. We have some automation over Terraform. If you are interested, I can talk about that later, but definitely not today. But the main thing for us, there is a new type of resource you may want to know. So we still have AWS instance, but we also have AWS Route 53 record. As we own a DataStax training domain, I can easily create domain names with AWS Route 53 resource record type, give it a name, give it a zone ID, and I will have DNS server configured. So every time you get training instance on our training, you are going to have also your instance as it is, but it will has a name like workstation, some unique ID, event name like KubeCon 2020, datastackstraining.com, and that's also completely automated. And in the end, what matters for us, and the particular records, so how do we map them? It's the same reference. Records in this record will have AWS instance. Those are mine templates, but that's the name of the instance we are rendering at the moment. So AWS instance. And finally, what property we will use? Public IP. So, oops, wrong one. Yes, public IP. So in the end, we will have things like that delivered automatically with all the domain names, and I can use not only names, but not only IP addresses, but I also can use domain names to reach my servers, and that's of course much more convenient. And then finally, when I want to wipe it out all, I can simply say Terraform destroy. Don't do it on your production. And don't ever say Alex told you to do so, because I didn't. We apply Terraform destroy only because we can wipe a whole infrastructure. What would be another way for me to clean up a system? Remove the resources from the files. So if, for example, I go to the file and let's say cut off, that's my AWS instances, boom, and I want to remove database, for example, I cut it off, it's empty, it's deleted, nothing. And now I'm going for Terraform plan, and who can guess what will happen? Okay, there is a mistake because I'm using this instance in other instances. On worker is going to use this one. Okay. I'm to return this one. It was a bad example, sorry. I'm going to remove the result first. And I'm going to remove result IP because we're together here, and result IP reuses result. So now that should be better. Terraform plan, and now it will be, so refreshing state. How about our nodes? Is everything fine? And final plan will be 0 to create, 0 to change, 2 to destroy, because I've removed two nodes, because I removed a node and elastic IP for that. And I again can say Terraform apply, boom. So we will be wiped out, And after that, I actually will break this one because I want a complete destroy terraform destroy. So it of course will ask me if I'm sure what I'm doing. And the value will be yes, I'm going to destroy all of them. Okay, so while we are waiting for them to be removed, there are some last words I wanted to tell you because we are going to finish. What infrastructure as a code gives us? There are a lot of different features and benefits, but the main I want to mention: observability. Now you don't have to walk through all of the availability zones on your EC2 instance if you're using AWS EC2 service to find all of the hidden Elastic IPs or whatever servers. It's much easier to walk through the configuration files. Traceability. Now, if you use proper Terraform plans and you use Git to commit your changes, because that's incredible. Now your infrastructure is a code, is a file, and you can git commit and git push. For the DataStax training, I don't do that, but for my previous project, I used a very complex combination of Jenkins plus Groovy plus Terraform plus Git, and every change was not only pushed to AWS or OpenStack or our DNS provider, which wasn't Route 53 at those times, but it also was pushed to Git. And in any moment of the time, I've seen the change set and who did the changes in GitHub. Well, that's really great what you can see history of the changes of your infrastructure as a real Git commits, normal Git commits, and you can make Git diff, Git blame, and so on. Then
Blame.
Yeah, Git blame. Every disaster has a name and a job title, you know. Good. So fast deployment or faster deployments. I can say what without multiple resource records, as I said, AWS Route 53 works very slowly. We were able to create hundreds and hundreds of servers within 10 minutes maybe, things like that, if you don't overuse provisioning. So try to move provisioning partially to creating a new AMIs pre-configured for you, and then move provisioning to the configuration management tools, which will do a post-provisioning after the node is added. If you do everything right, with proper configuration management and infrastructure management tools, configuration management and infrastructure as a code tools, speaking about of observability, you will have all your new nodes directly added to your monitoring with 0 steps done from your side. Well, as soon as you have configured that, of course. So traceability, fast deployments, reproducibility. You can have the same set of Terraform files to be applied to multiple different systems for your testing, for your staging, for your, I don't know, for any kind of your infrastructure. You can use the same files and they will be reproduced as they are on the production. And rollback capability, you added some nodes, you see what git commit, git push, Terraform apply, or well, commit push better to do after the push, and you see what nodes it's not what you want. Okay, you can have all the git tools you usually have with all the abilities to wipe out recent commits, and you just simply do Terraform apply again. Terraform sees what these 3 new nodes are missing now in the configuration files, and it's a good time to wipe them out. Be careful, that's not a direct rollback, and there can be some narrow places, let's say. but that's definitely what I'm happy to have in my infrastructure. Now, few last words. Forewarned is forearmed. Terraform, 6.2k thousand forks, almost 25,000 stars, more than 1,500 contributors, still in development, latest stable version 0.13.5. I know a lot of companies using Terraform on production. That's for you to decide if your policy allows that. Then, many people think, okay, Terraform is an abstraction layer. As I have Terraform, I don't have to think on AWS or GCP or any other cloud provider. That is a mistake. Or I would better say, that is the mistake. Because you still have to understand how AWS works. As Henrik Barcelos said, if you don't understand how AWS works, Terraform will not make your life easier. Indeed, it might make it worse. And that's absolutely correct. That's not an abstraction layer. You still have to understand what's going on downstairs. Now, Terraform definitions are cloud specific. That's again to discuss if it's vendor agnostic or not. You may call it vendor agnostic, but definitions are definitely cloud specific. And on large infrastructure, state update may be very slow on large infrastructures. If you work from multiple machines with Terraform files, it's in general will be can be a big problem, and I suggest to have one central place to store Terraform files and execute the changes. It's not the single point of failure, as long as you can clone your repository with Terraform files and run your commands from another server. But in this case, you may avoid some time expenses for some cases. I mentioned it many time ago, one last time, infrastructure as a code is not the same as a configuration management. Don't try to replace Ansible or Chef with Terraform. They are for different purposes. They are great. They make a great team. Thank you. We are done for today. And we have, I'm afraid, no times left for questions. Cedric, do we have any maybe good questions to answer?
So we had a question about security, but I replied that most security files are local files, not part of the config in Terraform. And if you want to store password or anything like that, they are externalized. And this is the role of Chef, Ansible, or any configuration management. But we had a great question just a couple of lines before, just only one. Oh, geez, I lost this question. I mean, we got a very good question.
I see.
Yeah.
I would love to hear about Terraform automation stuff you guys have
yes,
developed.
this one. Maybe the Jenkins pipeline stuff you did.
Yeah, so it deserves a separate talk, but the general idea is very very simple, so I can show it, I guess. So I will SSH to Mr. Jenkins again. Hey there, perfect. So take a look. I have here a bunch of template files. Those are simple text files. Those looks like Terraform files, but also have some placeholders. Let's say a machine learning workshop. Very well. So there are some resource records and blah, 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 blah. And they have some substitutions. That's a Groovy native templating. Groovy is a programming language which is executed in Java Virtual Machine. And what happens? How happen for us? What we have a template running as a live one. In the live folder, we don't have any active files because there are no active instances running. We have only security groups, key pairs, and so on. So that's how it works. Easy to show. We have here the main thing, which is a create infrastructure job. And main thing in the create infrastructure job is a Groovy pipeline, which gets, first I want to show how do you start that. So you go with build with parameters. If you have no experience with Jenkins, Jenkins is a build server, which I prefer to call an automation server. Because, well, with Jenkins doesn't look so nice, but with Jenkins I can do everything. Whatever you call, I don't know, Bamboo, GitLab, and so on, GitHub Actions, they have no comparison with Jenkins, and from the from the capacity point of view, Jenkins is much more powerful, let's say, and much more configurable. So I can define an event name, let's say test, and which template I will use, let's say this one, and user count, so how many nodes I need. For now, one will be completely enough, and I can say build. And what Jenkins does, while it works, we can take a look at the logs, by the way. Now we see some familiar names. So you see this command, user local bin terraform apply auto approve parallelism 40 refresh false. So in first part we render the template and we create a real test123 file. So I can switch back to this one. Now we see this test123. I can say cut test123. And you see what all the placeholders now gone. And those now are real names used by all the things. So we have all the resource records like that. And now it applies those changes. It will not do a refresh state, because when we have like 1000 servers running, refresh may take a while and we want to save time. It's the same, oh, it's too small, I guess, sorry. It's the same reason why we use parallelism 40. Default is 10 if I am not wrong. And well, auto approve should be pretty clear. So it does all the job, waits for the node to be initialized. We'll do some steps there to configure. Again, that's not a perfect scenario. I have to rework it to use Ansible maybe. Oh, connected. So we will do some more steps and boom, we have this infrastructure running. And I think that's great. And now I push button 1. If I would push button 500, I would have 500 of the servers. Okay, so this one is configured. Now we create resource records. And as said, AWS Route 53 is somehow pretty slow. I have no idea why. It looks much easier when to create a node, but it's slow. Okay, apply complete. 5 resources added, 0 changed, 0 destroyed. 5, 1 is a node, 4 are resource records, I guess. And I can use this address and open this node, and I have this server running. I will terminate it in a couple of minutes, but for now it's available. And finally, how job looks like, so how exactly it happens. We go to configure part, and that's a pipeline build where I can use Groovy. So basically that's the whole build. I cannot make it full screen, I'm sorry. There is no button to make it full screen, I guess. But in short, that's the whole job. At first, we generate a name for the instance. We read the template file as specified in the build parameters. We render this one with the properties we have. So that's just Groovy, simple template engine. And when we render this file as much times as the variable user count, so it was done only 1 in this example, but it will do as much times as I request. We make the binding and we render this template. And finally, we have this file appended, and last step is to execute template. And again, we are running this Terraform apply auto approve. That's it. Now notice, this script shouldn't be for you as a production example, because it's not. It was proof of concept, and it requires a lot of work, error handling, try catch, and so on. So this is a very proof of concept state, but that's how it works. We use Jenkins and Groovy to render a template, put it into a file, and when we use Terraform apply, to ask Terraform to do the job for us, then I think this one is done, and I don't need this instance anymore. I simply go to Jenkins delete infrastructure job, build with parameters, event name, build, boom. Node will be terminated within a minute. This automation is not publicly available to play with, but I did a talk about that at Hashi Talks, HashiConf event 2 years ago, I believe, or yeah, 1-2 years ago, something like that. And I plan to speak again about that because that's in general pretty great topic. Terraform is great, but when you need to have 5 developers needed to have access and change something in the infrastructure from time to time, when of course it's not going to be easy. And moreover, in some cases, imagine we have on my last project, we have a team of 16 people actively developing many things all the time, and it was a huge distributed system which is not easy to test. So complete automation was like people are pushing to GitLab and making a pull request or merge request, pull request in GitHub terminology. As soon as a merge request, a pull request is created, GitLab notifies Jenkins via API hook what we have a new thing here. Then Jenkins automatically provisions a new infrastructure on AWS for test, deploys everything from this branch and all the dependencies, builds everything and put it to this new infrastructure. And as soon as merge request is verified by tests and by quality assurance team and merge request is deleted or merged, this infra will be automatically deleted again by Jenkins. And that's like under full power, this teamwork of GitLab or GitHub and Jenkins and Terraform in Groovy is extremely powerful automation tool. I will be absolutely love to speak about maybe later, but definitely not this year, sorry. It's going to be a long story. As you see, we have a lot of things to brush up first before we will do any talks about these topics.
That's cool. The more talk we are doing, the more topics come up. So Jenkins, Ansible, perhaps. So more stuff we are showing, more talks to come.
Yep. Okay, so and finally, I hope I've answered all of your questions. We are out of time completely, and I have to say goodbye. But it was
or see you later, because we will do the same session in a couple of hours.
Yeah, we do the same session in a couple of hours. I guess. Yeah, we will do the same session in a couple of hours, or better to say in 2.5 hours, something like that. And same content. Feel free to join us, but what's important, don't forget, we are DataStax developers. Subscribe to our YouTube channel. It's directly under Cedric. And you have a special form to subscribe to all of our events. As you see already, technical talks from engineers to engineers, no marketing, open source things, and a lot of things. This DataStax Monday learning for any kind of open source technology, and our Cassandra workshop series for Cassandra related things. So Apache Cassandra, Cassandra plus Spark, Cassandra plus Kafka, and so on and so forth. And this week is very special because you can join our workshop on Wednesday and Thursday, and see how to pass the certification. So we help you to prepare yourself for the certification and pass the exam. And again, thanks to DataStax, that's completely for free. You can become a certified Apache Cassandra developer or administrator. That's for you to decide, or maybe even both, because voucher
Yeah,
allows you to make 2 attempts. So if you are successful on the first one, you can also take second one for the administrator or developer, like depending on what you took the
which
first.
is cool.
Yeah, that's pretty cool. Cedric, thank you so much for your help today.
Oh, I was pretty quiet. Tried to do my best for the question, but we had a very good question. And you know what? I learned a lot with you,
Thank you.
as
You
usual.
know why we have good questions? Usually our talks for developers, but that's infrastructure thing. We have less people, ops people, but they're asking more to the point questions. Sorry, just kidding. I don't mean to insult any developer. That's just a joke. Okay, then. Thank you for coming. Thank you for staying with us. I see so many people here still. Nearly everyone stayed till the end, and that's really gorgeous. So we will make. Thank you, Siva Kumar. Thank you, all the others. GitHub link I'm to create within next half an hour. That's definitely will appear, as Cedric said, at github.com datastacksdevs. Absolutely. And I will publish this link also on the next workshop. And you know what? I think we will ask Jack Fryer to send an email with the materials to everyone who subscribed for us at Eventbrite.
Yes, yes. He's probably listening to us
Yeah,
already.
I think so. Sorry, Jack, again making some work for you.
Ah, you think you were safe with no mentee? Hey, hey, hey.
Yeah, in a couple of weeks, I think we are going to have 90. Okay, everyone, so a little bit of music in the end, and see you again later.
See you.
I